So let's make another Arduino TensorFlow Lite program using the Portenta. Here's my Portenta. Here's my GitHub. Here are the main links I'm working with. And here's the Arduino. And something I didn't check on the other ones is just to remind you about libraries in Arduino that you would need TensorFlow Lite. And if you just type in Tensor, you would get, I don't know why that's there. Oh, there we go. Arduino TensorFlow Lite. I've got it installed. It looks like it's the latest version. There is also Adafruit, and I think that's been updated. There's Eloquent, and there's for the ESP. So this is the one you need. Now, I'm going to do something a little different than the xOr example. This is testing how big a machine learning model could be put on an Arduino. And so if you go into, there's my main page, if you go into my O9 TensorFlow or M09 TensorFlow, and we're going to come up with the program layers. A reminder, when grabbing these, always go to raw. It just makes it easier to get the full thing. This program's really similar to the xOr one. In fact, this part of it might be exactly the same. I'll check it out in a minute. Let's just get the thing running. I'm on the Arduino M7 core. Like it says down there, I'm on COM10, which is not where I want to be. It's flashing green at the moment. So I should be on COM11, which is the boot mode, DFU utility, or whatever. And I'm going to run that. I might talk about it if it's extremely different, but there is a little bit of talking that I've got to do with explaining this. So in the M09 TensorFlow folder, there is something called FJS convert to Arduino header. And I typically use TensorFlow.js to make my models, and then I have to convert them. And that's a whole nother program. But if I go into this conversion area and I go to the first thing, it's a bunch of web pages. And this third one down here that says more layers is just going to generate. Oh, this is a whole nother program. Anyway, it's going to generate, I'm not going to train it as much. It's going to generate 100 node layers. In this case, to begin with, I'm just doing one. So let's do 3. Click the button, and it will generate an xOr badly trained. But you can see it's got 100 nodes in the first level layer, 100 in the second, 100 in the third, and then 1 as an output. Curious why it's not listing an input layer. Maybe this one doesn't have it. And so what this little program here is allowing enormous number of layers, making a really big model. And so that's what the program I'm going to run at the moment is. And let's just see, this is a really big model for a microcontroller. So let's go back to, this is still compiling. So let's talk about it a little bit. There might be some repeat. Reminder, typically you put the model.h in a new tab doing this thing, new tab, give it the name model.h, you would unbracket that, and then you wouldn't have this line of what looks like assembly code. One thing important with this is the length, because that's what you want to keep down. This is very small. This is probably a single 100 node hidden layer for the xOr program. Then we've got the advanced there. Basically, there's your include for TensorFlow Lite. I typically put Arduino in there. It's not really needed. Here are all the includes from TensorFlow Lite. Here is where I'm doing the core, the M7 core. Here's for the M4 core. I'm going to have to test that with the new version 1.3.0. Here's the Nano 33B LE, which I have to test with 1.3.0. And then there are some other ones. Here's for the Chow, the Arduino. And then this is, if it isn't defined, it basically calls the external debug and doesn't do anything. One of the issues with TensorFlow Lite is it has to have a way to print debug information. And that makes it very different for the different boards that do debug information quite dramatically differently. Then I've got a namespace. Then I've got a model setup. That's basically just calling all this stuff, loading it up. And then what else do we have? Namespace, model setup. And then model prediction. That's the main thing, is we're predicting whether, in this case, an XOR input is both zeros, both ones, or one of the inputs is a one, meaning it has electricity. I do things a little differently. Okay, so here's the main program. We're just using regular Arduino LED built-in. This is testing for type of tensor. Most of the ones I would be working with are probably float 32s. Here we are, we're reading at just doing some random stuff there, getting serial begin working, setting up my LED and setting up the model. And then it's a whole bunch of serial print lines. It's basically giving information about the model that has been loaded. This should kind of work for any model you load, but in our case, it's always going to be the same because we're loading the same type of model. A number of layers might be different, and so that would be interesting. So it's a whole bunch of print lines. It's just giving information, and then it's waiting 3 seconds and doing the whole thing over again. While I've got some time, let's go in and talk about this TensorFlow JS conversion to Arduino. See, I typically use, this is my site, it's ugly yellow, just so that you can tell it different from the ugly blue. If I go to the GitHub one, let's just see which one. That's the ugly blue ones. This is more update, the GitHub one, and it has a whole bunch of machine learning programs in it. I typically, the basic one is this 20 Keras, and that's the one I'm working with. And these things, we can go down to the bottom. I can run the program, run it. By the way, that has loaded and the Arduino is not flashing. Say I run this program, this one's training 3,000 times, so it's gonna take a while. But the cool thing is that we can save to disk the model we've just created. And that's really nice because it's all on a web page, nothing fancy there. But converting that model into something that can be run on the Arduino is a little confusing. So let's just go back to Arduino here, and our port now is the serial port COM10. And let's go look at the monitor. First of all, is it running? Yay, it is running. Second, what information is it giving me? And every 3 seconds, it's going to give it to me again. That's just so that I don't have to put in the code that kills the serial monitor until you load the serial monitor, and then the code doesn't work when you're away from a computer. So let's just have a look at the data it's giving. Oh, this one has 8 layers. Okay, well, that's reasonably big. First layer has 2 nodes. Just trying to figure out if it actually has 2 nodes or if it has 100. I'm thinking each layer has 100 nodes. But I'm not really sure for this model. I don't remember what model I loaded. Total bytes was 2420. It actually looks like this is my normal xOr program. I'm not quite sure why it's coming up with a whole bunch of layers. But let's go back to this. It has, I think I have to run the test. Oh, there it is. 0, 0, add, would not show up. Let's try 1, 1, 0. Oh, darn, wrong thing. Test comes up as 0.93%. That's a correct answer. If they were both 1, it should be a very low answer. And yes, it is. That's very low. That's 8%. And that's running correctly. The nice thing here is I could save to disk that model. Okay. And this model at the moment only has 41 parameters. So it's a very small model. It looks like this is my typical XOR that has the 2 inputs. There are my 2 inputs, a 10 hidden layer, and then a single output. And hopefully that's this. I'm just not quite sure why it's coming up with multiple layers there. So let's go have a look at how to do this conversion. And I use Gitpod to run these things, but basically you would install, do these installations, mainly those 2, and then you would run a command like this to do the conversion. Okay. And notice the last command, this converts it into TF Lite. This first conversion converts it into Akira's model. This one, and it looks totally confusing, but we just run the exact same command each time. I'll write a whole program, movie on this. And here we go. We convert from TF Lite, TensorFlow Lite, to a model.h file, which was the model.h file here. And at the moment, I just wanted to show this one going, and it is running, and the serial monitor is running. I didn't want to go into the whole conversion thing. So, video done.